So let's continue with our this series on NEET PYQ. Our next question here is, if a ball is thrown vertically upward with the speed u, okay, the distance covered during the last t second of its ascent. Okay, so what is happening here is, let's say a ball is thrown from any point A and it is going here to any point B, right? They are asking how much distance it will cover in the last t seconds of its ascent. So last t second means, let's say it was from point C to B. When it was going, it took t seconds. While traveling from C to B, it took how much time? T seconds. And in that t second, how much it traveled? The length of BC we have to figure out, right? Now to figure out the value of BC, we have to first find what is the initial velocity over here, C. Because while going from A to C, the final velocity at C will be initial velocity in the journey from C to B, right? So let's figure out first that. So first of all, what are the given data? The given data is initial velocity is u. Initial velocity with which this ball is projected upward is u, correct? Now, if it is projected with the speed u, let's see what is the total time of the journey. To figure out that, v must be equals to u plus at. I hope this is clear. Now, what is the final velocity when it reaches at the highest point? At the highest point, the concept here is velocity must be 0. So, v will be 0 and this will be u, 0 equals to u, and a will be minus gt, correct? Acceleration due to gravity is g. So, let's take this g on the other side, and this will be gt will be equals to u, and t will be equals to u by g. This is the time taken, okay? Or let me just, because the t is same, to avoid the confusion, I am just taking this t as capital T here, right? So let me take it as capital T minus G, and this is capital T. So this will be G, capital T equals to U, and T will be equals to U by G, correct? So this is the time taken for the ball to reach at the highest point, which is at point B. This is the total time. Now, how much time will be this part? So this part will be T minus T, correct? If from here A to B, it is taking time capital T, and small t is while going from C to B, then the remaining journey A to C will be T minus T, correct? Now, using this, let's figure out what will be the velocity at point C, correct? So velocity at point C will be Vc, that will be equals to initial velocity U plus G, and what is the time taken to go from A to C? It will be capital T minus small t. I hope this is clear. Correct? Vc is the velocity. We are looking at point C, and that will be final velocity when it is starting its journey from A. So A to C it is going. Final velocity is C. U is the initial velocity at A plus G into time taken while going from A to C, which is T minus T. Correct? Now, U is how much? U is already U, initial velocity. G, and what is capital T? Let me just first open this bracket and then substitute here. It will be G into small t, correct? I hope this is clear. Now let's substitute the value of capital T over here. It will be equals to U plus G into how much it is? Capital T, U by G. So let me write here U by G minus GT. G and G cancelled. How much we got? Now be very careful. When something is going up, our equation will be here negative here. So this is a small change we have to do. This will be negative over here. This will be negative over here, correct? And this will be negative, U minus G, correct? Be very careful. Okay, so when it is going traveling up, there is a negative, okay? We have seen that in this equation also. So this will be G and G cancels. We left with U minus GT. And that will give us minus GT, and minus minus, that will become plus, and this will be plus GT, that is the velocity at point C. Now, final velocity at point C, that will be initial velocity while going from C to B, correct? Let me repeat again. Final velocity after reaching at C will be initial velocity while going from C to B. Now, if this is the initial velocity while going from C to B, let's figure out here how much the distance covered while going from C to B. Okay, so to cover the distance, or to figure out the distance, which equation we will use? We will use the equation v square minus u square equal to 2as, correct? Now, what is v square? Final velocity at point B, that will be 0. U square, the initial velocity at point C, that will be how much? Gt square. So g square t square, and that will be 2 into minus g while going up into distance s. We have to find this s, correct? So let's take this 2g on the other side. It will become half g t square. That will be our distance traveled in the last t second of ascent. So that is option D, half gt square. I hope this is clear. You have to be little careful while dealing with the negative sign. Okay, when it is traveling upward, the velocity obviously decreases, and as the velocity decreases, there will be a negative sign, right? So if I'm throwing this pen upward in direction, the velocity decreases for this pen, right? Then only it will become zero at the highest point. Otherwise, if the velocity is increasing while going up, how come it will reduce to zero? So you have to be very careful with the negative sign. Let's see the next part. Next question. A stone is thrown vertically upward when the stone is at a height half of its maximum height. So let's say this is our maximum height from A, B here. A is the maximum height, let's say, and half of the maximum height, which is this. So if this is h by 2 and this is also h by 2, I don't know what is the value of h. Let's come back to the problem. When stone is at the height of half of its maximum height, its speed is 10 meter per second. So over here, its speed is 10 meter per second. Fine. Then the maximum height of the stone, means maximum height of the achieved by the stone, will be how much? We have to figure out, right? Let me explain you the question once again. We are throwing the stone from any point B to point A, right? I don't know what is the length of this AB. Okay, so they said that at half of the total height. So if the total height is 10 meter, let's say, just an example, then this is 5 meter, this is 5 meter, right? So at this point, when it reaches the 5 meter, its speed is given how much? 10 meter per second. Okay, I don't know what is this 5 meter, it can be 2 meter, it can be anything, right? So we have to figure out the total height it has traveled. Okay, great. So here we don't know what is the velocity at point B, but we know that the velocity at this point is zero. Why? Because at maximum height, the velocity of the particle is zero. Then only it is maximum. Otherwise, it would go little more up, right? Okay, so let's figure out here. V square minus u square equals to 2as. We will use this equation. So what is the final velocity at point A? 0. What is the initial velocity? 10 meter per second. So let me just write here 10 square. 2 into acceleration minus 10. Why minus 10? Because it's going up. Distance, we have to find s. Now here the distance s is h by 2. So I'm just writing here s as h by 2 here. So this will become how much? Minus 100 equals to 2 and 2 cancels. We left with how much? 10h. So minus. So this will become 10 meters, that is equals to the total height h. Is there such option? Yeah, option B is correct. 10 meter is the total height, correct, of this whole thing. We have directly found the value of h. Okay. Instead of h, if you were taking s, later on you will have to double it, because you are assuming that this is s. If this is s, then the whole journey will be 2i. 2s, okay, twice of s. Let's see the next one. Great. Let's see our next problem. Our next problem says a car moving with a speed of 40 km per hour. So this is our u. Initial velocity is 40 km per hour. Great. Can be stopped after 2 meter. Now be very careful. Here it is kilometer per hour and here it is 2 meters. So you have to do the unit conversion. Unit conversion is very important in this particular problem. Why? Because kilometer per hour and meters. Be very careful. Okay. So distance here is 2 meter. By applying brakes, if the same car is moving with the speed of, so u1 is this, s1 is this, u2 is equals to how much? 80 km per hour. What will be the minimum stopping distance? S2 you have to find. Okay. To calculate the stopping distance, you already know the formula. Okay. Direct formula you can do. I will derive that formula just to recall what you have done already, right? The final result you can use, and conversion is not required in that particular thing. You can directly do it because it is a ratio, you can see. Okay. But here we will do, we'll make use of this equation. V square minus u square equals to 2as, and if something is stopping, v will be 0, and if it is retardation, so a will be negative, because you are applying brake, retardation is there, right? So a will be negative. Minus u square will be equals to minus 2as. Okay, so acceleration a will be equals to minus u square upon minus 2s. Okay, I hope this negative went, and acceleration in both the cases will be same, right? Because car is same, so acceleration will be same, force applied will be same, right? So a in both the cases are same, so I can say u1 square upon 2s1 will be equals to u2 square upon 2s2. I hope this is clear. Yeah. And as you can remember, 2 cancels out. u1 square upon u2 square is equals to s1 upon s2. Okay, directly. Now most of the times teachers, they say that you have to remember this relation, right? But this is the core concept behind this. Let's come back to our problem. Substitute what is given. So do we have to convert kilometer per hour into meter per second? Not required here, because it's a ratio. You can see that even if you multiply 5 by 18 here and 5 by 18, the both will cancel out, right? So no need of doing that, okay, making it more complicated. So u1 is straight away 40, so 40 into 40. Even if you are doing 5 by 18, that will cancel out down, okay. u2 80 kilometer per hour, so 80 into 80. S1 distance, stopping distance for the first one. Stopping distance for the first one is 2 meters. S2 we have to figure out, right? So let's simplify this further. Before that, let me cancel out this with this, this with this. 4 ones are 4 ones are, and 2 twos are 4, and that goes that side. So S2 will be equals to 8 meters. That's our stopping distance for the second case. So S2 is 8 meter. Is there any option? Yeah, option A is correct. I hope this is clear, right? So this was most of the times teachers say that just remember this expression. You can substitute it directly and figure it out, right? How we got this expression, that you can see in this particular case. Let's see the next question. Great. Our next question is, if a car at rest, so initial velocity is 0, accelerates uniformly to a speed of 144 kilometer per hour. So let's multiply 5 by 18 here and make it meter per second. In time 20 seconds, because there is 20 seconds, that's why I converted here into meter per second, right? Otherwise, if it was in hour, we would have taken it as kilometer per hour, right? It covers a distance of s, you have to find, correct? So initial velocity is 0, v is this, t is this, s you have to find, okay? And it is accelerating. If it is an accelerated motion, you have to first find the acceleration, right? And then you can use s, okay? So first of all, to find acceleration, v minus u equals to at, and a will be equals to v minus u by t. I hope this is clear. Now, what is the value of v? Let me simplify this. So 6 3s are, and 6 2s are 12, and 24, 3 8s are, 8 5s are 40. 40 meter per second it is. So final velocity is 40, initial is 0, time is 20 seconds. So this will be how much? 2 meter per second square. That's our acceleration. Now, if this is our acceleration, we can straight away use an initial velocity is 0. So s equals to ut plus half at square. So half at square straight away, because u is 0, right? If initial velocity is 0, straight away use this, and this will be equals to half. What is our a? 2. And what is our time taken? Time taken is 20 seconds. So straight away 20 into 20. Now 2 cancels with 2, and you're left with 400 meters. Is there any such option? Yeah, option C is correct. Simple problem, right? Again, I'm repeating, all these questions are PYQs, okay? And we are solving this, okay? This is our 5th lecture on our this series. Most probably one more lecture and then kinematics is over, okay? All PYQs will be done. Then we'll go for the motion in plane part. So let's see the next one. Great. If a ball is thrown vertically upward with a velocity 40 meter per second, so initial velocity is how much for the ball? 40 meter per second. Then the velocity of the ball after 2 seconds, t equal to 2 seconds, will be how much? Now, when something is going upward in direction, it is obvious that the velocity decreases at each and every instant, right? If it will not be 0 at the highest point, which means it will go further. So simply we know that as we are going up, things are getting slowed down, right? So v will be equals to u plus at, correct? V equals to u plus at. We have to find the final velocity. U is the initial velocity, a is the acceleration, t. U is how much? 40, and acceleration is minus g. Be very careful, as you are going up, it will be minus g. So I'm assuming g is 10, so minus 10, and time is 2. So this will be equals to 40 minus 20, and that gives us 20 meter per second. So after 2 seconds, its velocity reduces to half of its original value, that is 20 meter per second. That's our correct answer. Correct? Understood? Let's see the next question. Okay, question says, a body dropped from a height. If it is dropped, its initial velocity is 0. If something is dropped down or released, okay, or dropped, its initial velocity, it's obvious that it is 0, okay. So a body is dropped from height h. So let's assume that this is our height h, okay, with initial velocity 0, because it's dropped already, it is given, strikes the ground with a velocity 3 meter per second. So at this point, when it reaches, its velocity is 3 meter per second. Great. Another body of same mass is same, mass is not changing, is dropped from the same height. Great. So you are releasing another body from here, same height h, with an initial velocity. Basically this time you are throwing it. Previously initial velocity u1 was this, okay. So u2 is how much? 4 meter per second. So now you are throwing it, okay. The final velocity of the second mass with which it strikes the ground, okay. Question is clear? So basically you are taking first object, you are taking this pen, and you are simply dropping it, So when you are dropping it, what is happening? You are not giving some velocity, but second time when you are throwing it down, you are giving it some velocity, 4 meter per second. And in that case, in traveling the same height, what will be the final velocity in this case, right? So let's assume the first scenario. In the first scenario, u was 0, V is equals to this. In the previous lecture, if you have attended, I have given you a direct relation how we got that. Okay, so let me remind you, velocity with which something reaches the ground, it will be root 2 gh, provided here the initial velocity was 0, right? Initial velocity is 0, in that case v will be equal to root 2 gh. So this will give you v square will be equals to 2 gh, correct? So v is how much? 3. So 3 square 9. G, let's take 10 if the question is saying. Okay, let's assume it as 10, and height we are looking for. So h will be equals to 9 by 20 meters. So what is the height of this building or tower? The height of this building is how much? Here it is 9 by 20. Now if it is traveling 9 by 20, okay, let's use the same equation now. Now can we use this equation now? No, this is for initial velocity being 0. If the initial velocity is not 0, let's use again v square minus u square equal to 2as. What is v? We are looking for. What is the final velocity of the second case? Second ball is we are looking for u square. U square. What's the initial velocity? Sir, initial velocity with which it is dropped is force. So 16. 2, g is 10, and distance is how much? How much it has traveled? 9 by 20. Correct? I hope this is clear. Okay. Now, what we will do, let's simplify it. 20 cancels with 20. V square minus 16 is equals to 20 cancels with 20. 9 you left with. Let's take 16 on that side and add it to 9. So 9 plus 16 will make it 25. So velocity with which it will hit the ground will be 5 meter per second. Correct? Is there any option? Yeah, option A is correct. Velocity with which it hits the ground is 5 meter per second. I hope this is clear. Let's move to the next question without wasting time. Great. The question says the acceleration of a particle is increasing linearly with time t. So it's a acceleration which is variable acceleration, and variable acceleration a is how much? It is increasing linearly with time t. So a is bt. The particle starts from origin with an initial velocity v naught. Origin and initial velocity is how much? V naught. Initial velocity means when the time was t equal to 0, x is 0, but v is v naught. Be very careful. Here we will make use of few things. The distance traveled by the particle in the time t will be how much? Okay, great. So if a is bt, we know that a is nothing, v is nothing but integration of a dt. V is nothing but integration of a dt, right? Let's substitute here a and we will get velocity. Velocity will be integration of bt dt. Now b is a constant, we can take it out. So it will be b t square by 2 plus constant c. Now in case if you are not familiar with integration, let me remind you once again. Whenever we integrate, okay, indefinite integrals, this we usually do in maths. Okay, so if you integrate, you always get a constant here. Okay, the constant value is dependent on initial conditions of the given problem. And what are the initial conditions? The initial condition is when t at t equal to 0, v will be equals to v naught as per the problem. T equal to 0, v equals to v naught. So let's substitute here t equal to 0. So the left side will become v naught. This will be 0 plus c. Let me repeat again. Putting t as 0 here, this expression will reduce to 0. V will be equals to v naught, and that will be c. So v naught will be equals to c. This is our value of constant. Let's substitute it back here. So velocity function will become bt square by 2 plus v naught. This is our actual function. Velocity function. If this is our actual velocity function, let's figure out our displacement or distance function, right? So let me integrate it. So distance will be x, that will be integration of v dt. Correct? So this will be integration of v dt. V will be equals to how much? Bt square by 2 plus v naught. Correct? dt. Now b by 2 is a constant taken out. Integration of t square, that will be t cube by 3. Integration of t square will be t cube by 3, right? B by 2 is constant taken out of the integral. T square is t cube by 3. Plus v naught is again a constant. Integration will give us t here. Okay. Now in case if you are getting some problem or difficulty in here, this part, just go through your integration part once again. This will be cleared. Okay. How I got this. Now plus a constant c. Whenever we integrate, we get a constant at the end, right? So this can be written here x as bt cube upon 6 plus v naught c plus c. Now problem says when t was 0, particle was at origin. So when t was 0, x will be 0, right? So let's substitute here. Putting at t equal to 0, x is equals to 0. So let's substitute here 0. This will become 0 because t is 0, whole thing becomes 0. 0 and plus c. So c becomes 0. So c is 0. So our final expression for this is removing this c, okay, or I'll just remove this part, okay. You can, if you have not understood, just watch it again, go back and watch this part again, you will get it, okay. So we can remove this c here. Why c is 0? Because initial condition says, so our this will be x value, our distance. So bt cube by 6 plus v naught t. Is there such option? bt cube by 6 plus v naught t, that's option C is correct. Clear? Let's move to our next question. Great. The next question says 3 different objects of mass m1, m2 and m3 are allowed to fall from rest. So initial velocity is 0 from the same point O along 3 different frictionless paths. So there are 3 different paths and all 3 are frictionless, like this, okay. Any path is there, okay. The speeds of the 3 objects on reaching the ground, okay. Now this is very crucial part you have to remember whenever you release any object. I have discussed it, this particular thing, in the previous lecture also. In case if you have not watched, go through it, link is in the description, you can see it. So if you are releasing any object or more than one object from the same height, okay, moment it reaches the ground, they will have same velocity. So the velocity condition is what? Same time and same height. If the time is different or if the height is different, things will be different. So the speed of the 3 objects on reaching the ground will be in the ratio 1:1:1. Why? Because they are released from same time and same height, regardless of path. Now path is frictionless. If there is a friction, then things will change. Conditions are there, okay. So you have to focus primarily on conditions. What are the conditions? Height should be same, time should be same, and it should be frictionless, right? Let's move to our next problem. Beautiful problem, okay. Now there are different complicated ways to solve this particular problem, but we will solve it in a very simple trick, okay, very simple manner. And how I got the basic of this particular trick, for that you have to watch our first initial lecture. There I have solved how I got this particular thing, right? So the water drop falls at regular interval from a tap 5 meters above the ground, okay. Let's say this is our tap, and this tap is at what distance? It is at a distance of 5 meters above the ground, right? Okay, the third drop is leaving the tap. So let's draw here a third drop. Let me make a drop here. Let's say this is a third drop leaving here, okay, the tap instant when the first drop touches the ground. So let's say the first ground, this is ground, so first drop is over here. How far above the ground is the second drop at that instant? So this one we have to figure out. Great. So I hope you are clear with the basics, okay. Let me read this part again and let me explain you the concept. The question says there is a tap, and from that tap water drops are falling down at equal intervals. It has to be equal interval, right? Then when the third drop is on the nozzle of this particular tap, the first one has already reached the ground. They are asking what will be the distance of this second drop from the ground, okay. Now there are different ways you can use equations of motion and solve it and make it more complicated. Let me just give you a very simple trick, and this trick is based on our first lecture, right? Initially I have explained you how I got that, okay, in that particular lecture, so you can watch it how I got this. Let me just remind you from that lecture that this gap is nothing but distance s. This will be any distance s. The gap between first and second and the third drop is s. The gap between second and the first drop will be 3s. Sir, what if instead of 3 drops, if they were giving us 4 drops, then the gap between third and the second, you go in the opposite order, right? This is your third, this is your second, this is your first, okay. So when there will be one more drop, it will be first, second, third, fourth. So gap between this one and the next one will be how much? If you remember the previous lecture, 5s, right? It will be 5s if you have watched the previous lecture. Great. So this gap is s, this gap is 3s. What should be this whole total gap? So the total gap will be s plus 3s. And what is s plus 3s? It is 5 meter given here. This gap is s, this gap is 3s, right? What is s? We don't know. In terms of 5 it will be, sir, okay, what if there will be instead of 5 it will be 10 meter, then also it will be s and 3s? Yes. If it is 50 meter, regardless of what is the height, this will be in the ratio 1:3. 1:3:5:7. We have already discussed it in the previous lecture. So s plus 3s, it will be how much? 4s. That will be 5. So s will be equals to how much? 5/4. S is 5/4. I hope this is clear. This is our 5/4. But they are asking how far above the ground is the second drop at that instant. Second drop is at what distance from the ground? So this 5 by 4 is the top one. The low one will be 3 into S 5 by 4. So that will be how much? 15 by 4. And this 15 by 4 is how much? That will be 3.75 meters. I hope this is clear. Okay, so when you divide 15 by 4, you can get this using equations of motion, putting the equal time intervals. Okay, using that concept you can find it. That will be little more complicated. This is a straight away direct, very simple problem. Okay, many students they get stuck here. So if you remember the concept of S, 3S, 5S, it will be very useful in such scenarios. Let's see the next one. Okay, our next question says a body is thrown vertically upward from the ground. It reaches a maximum height of 20 meter. Okay, vertically upward from the ground and it reaches a height of 20 meter. So this is our 20 meter in 5 seconds and this is the maximum height. So let's say this is A to B. So a body is thrown from A to B 20 meter in 5 seconds, right? It looks 5 seconds. Okay, after what time it will reach the ground from its maximum height? Position, very simple, straightforward. After what time it will reach the ground from its maximum height position? Same, 5 seconds. Yeah, the amount of time taken by the object to go to the maximum height is equal to the time taken to come back, right? We have discussed it in projectile motion also and direct these questions also. Let's see the next one. Okay, a stone released with zero velocity from the tower or top of the tower. Zero velocity means initial velocity being zero. Okay, reaches the ground in 4 seconds. So time is equals to 4 seconds here. The height of the tower you have to find. Very simple, straightforward problem. Okay, so here time taken is how much? 4 seconds. Correct. Initial velocity is equals to 0. Final velocity we don't know. Okay, we have to look for height. We have to find the height. Correct. Okay, this is our problem. Take g as 10 meter per second. So we have equations. We can use v square minus u square, but for that we require v. Okay, we can use s equals to ut plus half gt square. So s equal to ut plus half at square. Let's use this equation. Distance we have to find. U is 0 straight away. Half g is 10. T square will be 16. Correct. So this will be 80 meters. Is there any option? Yeah, option C is correct, 80 meters. I hope this is clear. Straightforward problem from NEET PYQ. Let's see the next question. Great. The velocity of a train increases uniformly from 20 km per hour to 60 km per hour in 4 hours. All of them are in hours and kilometers, right? So no need of conversion. The distance traveled by the train during this direct question. So what equation we will use? V square minus u square equals to 2as, right? So what is v? V is 60 km per hour. So let's substitute here 60 whole square minus initial velocity u is 20 square, right? And this will be 2as. Acceleration is how much? We have to find, oh, acceleration is not given. Great. So then we have to first find the acceleration, right? And then solve it. So let me solve first. Let's figure out the acceleration first. So to find the acceleration, we will use v minus u equals to at. So a is equals to how much? V minus u by t. Let's substitute this over here. So v square minus u square will be equals to 2 into v minus u over t into s, distance, right? And v square minus u square can be written as v minus u into v plus u. Correct? Whole divided by, what is v minus u? V minus u is here and that will be 2 upon t into s. I hope this is clear. I simply took v minus u, right? Later on I'll take t and 2 that side. We cancel out these two. So this will be t into v plus u whole divided by 2 equal to distance. Let's substitute the values directly here and you will get the value of distance. So time taken here is 4, v here is 60, u here is 20 and whole divided by 2 equals to s. Correct? So this will be 2 and 60 plus 20, 80, 82 is a 160. So 160 kilometers, that will be our distance traveled. Is there any such option, 160 kilometer? Yeah, option A is correct. 160 kilometers is the distance traveled by the train. Let's see the next question. Great. A body starts from rest. U is 0. What is the ratio of distance traveled by the body during the fourth and the third second? Fourth and the third second. So you have to find the ratio of distance. Now we will use Sn, that is equals to u plus a by 2 into 2n minus 1. Correct? Now in the fourth second, S4, that will be u is 0, already given in the question, a by 2, 2 into 4 minus 1. correct? So S4 will be equals to A by 2 into 2 4 is 8 minus 1, 7. 7A by 2, correct? We don't know the acceleration because anyways in the acceleration in the ratio, the acceleration will get cancelled. Next is S3. S3 will be equals to how much? A by 2, 2 into 3 minus 1, correct? So this will be A by 2 into 5. That will be S3. Now if I divide both S3 and S4, what I'll get? I'll get S3 upon S4. That will be equals to how much? We have to find 4 is to 3. So I have done opposite. It should be S4 upon S3. That will be equals to 7A by 2. And there it is 5A by 2. Let's cancel out A by 2 with A by 2. I got 7 by 5. Is there such option? Yes, option A is correct. 7 by 5 is the ratio of distances traveled in the fourth and the third second. Let's see the next one. A body dropped from top of a tower fall through 40 meter during the last 2 seconds of its fall. The height of the tower you have to find. Great. So what we will do here is, let's say this is any point A, this is any point B. This is last 2 seconds it is traveling. From C to B it is taking how much? 2 seconds. And here it is traveling 40 meter. Clear? Let's assume that the AB height is H. H is how much? AB. So this will be height will be H minus 40. Correct? Let's figure out the solution. So what will be H? So initial velocity is what? Body is dropped. Dropped means initial velocity being 0. So S is equals to ut plus half at square. We will make use of this. U is 0 and S is H, the total height, half G T square. I am not substituting any value of G and T. Okay, this is our equation 1. What is this T, small t? Or let me just make it as capital T to avoid later confusions. Capital T is what? The total time it takes to reach the ground. First equation. Be very careful. Correct? Okay, this is first equation. Now how much it will travel from A to C? A to C will be H minus 40. So H minus 40, that is our A to C. And that will be equals to, again U is 0 in that case. Sir, why didn't you take this part? Because here initial velocity is not 0. First you will have to find the value of velocity at C point. That will be a problem. So first find the velocity at this. So U will be 0 in that case, half G. G will be how much? And time, if this is 2 seconds and capital T is the total time, then this will be how much? T minus 2 whole square. I hope this is clear. This is our equation number 2. We have to solve this equation. Let me clear this whole concept. What is happening here is total height is H and total time is T. So H will be equals to half GT square, right? Now, while going from A to C, the distance it will travel will be H minus 40. H minus 40. In what time? If the total time is capital T, this is 2 seconds, so T minus 2. So this will be equals to, let's simplify, H minus 40. That will be equals to half G. Be very careful while solving. T square plus 4 minus 2 to the 4T. I just applied A minus B whole square. Clear? Okay. 2H minus 80. I am just taking this 2 on the left hand side. 2H minus 80 will be equals to G multiplying inside. GT square 4G minus 4GT. I hope this is clear. Clear? Now what is GT square? GT square from first equation, it's 2H. GT square is how much? Let me repeat again. GT square is how much? Taking 2 on the other side, it's 2H. So I am writing here 2H. Okay, I'll write here 2H. So let's rewrite this equation. 2H minus 80 equals to 2H plus 4G minus 4GT. 2H gets cancelled with 2H. I hope this is clear. Now let's substitute the value of G and find the unknown variable. What is the unknown variable from this equation? It's T. So this will be minus 80. Be very careful with the signs. 4 into G, 40 minus 40T. Correct? I hope this is clear. Okay. Let's take this 40T on that side. Taking 40T on that side, that will be 40T over here on the left hand side. And 80 on that side, 80 plus 40, 120 here. So T will be equals to 3 seconds when you divide 120 with 40. So you got the total time from going from A to B is 3 seconds. Okay. If the total time is 3 seconds, can we figure out the height of this Yes, put here t as 3 seconds in this first equation. So let me solve it here only. Okay, this is our h. So to figure out our h must be equals to half g is how much? 10, and t square, which is 3 square, which is 9, cancels out 5 nines are 45 meter. Option B is correct. So I hope you are getting these. Okay, next will be the last lecture on kinematics, with which includes PYQ of this year also, means previous year, including graphs. We will solve the problems, right? So we'll continue in the next class.